Hello everyone, welcome back to my additional mathematics channel. For today, I would like to concentrate on the total distance. Let's get started with the class right now. Let's see this example. A particle moves along a straight line from a fixed point O. Its displacement as meter t seconds after passing through O is given by s equal to t squared minus 6t. Find the total distance traveled by the particle in the first 7 seconds. So basically, in order to find the turning point, we have to differentiate ds dt, and ds dt it means velocity. So when the particle turns the direction, velocity will be 0. So that means 2t minus 6 equal to 0. So t is equal to 3. This is actually very important concept. When the particle turns the direction, it will actually at the minimum point when the A is positive. So we want to know what is the displacement of the particle. So we substitute t equal to 3 and we found out the displacement is negative 9. It happened at t equal to 3 seconds. So 3 negative 9 is the minimum point. Then after that we need to find the x-intercept. So in order to sketch a graph, you have to follow all the steps. Find the x-intercept, let s0, then we factorize. So t, we will factorize the t, and then t minus 6 equal to 0. So t is equal to 0 and t equal to 6, right? Alright, so and then the other point that we need to find is the last point, which is when t equal to 7. Where is the particle being displaced to? The particle is displaced to t squared minus 6 times t. So we will substitute 7. So it means that it's at the 7 meter. Now let's try to sketch the graph. So we will label t as the horizontal and the s as the vertical axis. And then we will just plug in all the important points so that we can sketch the quadratic function, right? So the intercept is at 0, 6, and then we have to label the t equal to 7, and then the turning point is at 3 negative 9. Right, so let's label the point. We have 7, 7, we have 3 negative 9, we have 0, 0 and 6, 0. All these are important points. Okay, we have minimum point 3 negative 9. Make sure you label the minimum point because it is actually a must to label. Alright, so that is how you sketch a graph. Okay, this is called using graphical method. Alright, you cannot use a number line if the question asks for graphical method. Alright, okay, so we have measured everything labeled correctly. Show the point 7, 7. Alright, that is the we call as terminal point, the last point. Alright, so that is actually the quadratic function, but it's as in terms of the t. So we based on the graph, we will calculate the total distance traveled. That means the particle travel from 0 to the negative 9, right? So we make it positive because of the distance. And then when it come back to the origin, it will be 9 meter. And then from the origin, actually it go to the right 7 meter. So the total distance traveled can be calculated using the graphical method. 7 is actually original point to the ending point. So total distance traveled is 25 meters. Okay, so this is actually solving total distance using graphical method. Right, let's see question self-practice 8.2. A particle moves along a straight line from a fixed point O. Its displacement s meter t second after passing through point O is given by s equal to 4t squared plus t. Okay, calculate the total distance in meter traveled by the particle when the time is from 0 to 4. So let's see how. So when we want to find the total distance, basically we have to actually substitute the t0 where is the particle and t equal to 4 where is the particle, and measure is positive. Make sure the particle is not changing the direction, then we can just minus. Alright, so if we minus, we will get the answer for the total distance for the particle. Alright, so let's solve it out and we will get the answer for the total distance traveled from 0 to 4. Right, so then for the time t equal to 3 to time t equal to 6, for this one we have to be very careful. Right, it's not like just now we can just minus, because we need to study the movement of the particle by looking at the number line or by looking at the graph. Then only you will get the answer, which is 4 times 6 squared plus 6 minus 4 times 3 squared plus 3. Right, so the answer is 111 meter. Hello guys, let's discuss question number 2. A particle moves along a straight line and passes through a fixed point O. Its displacement s meter t seconds after it starts moving is given by the function s equal to 6t minus t squared plus 7. The particle moves to the right of O until t equal to 3 and then move towards O again. So that means it changed the direction. Find the total distance traveled by the particle in the first 2 seconds. Now, in order to answer this question, we need to study in detail the movement of the particle. So how to study in detail of the movement of the particle is, we have no other way. We have to find the displacement so that we can monitor how the particle move. Alright, so because our question is asking until 9, so basically if you have time, you can do until 9. If you don't have time, you can actually do the important point will do. What it means by important point, that means the starting point is a must to do. The starting point is compulsory, and then the last point, and of course another point is when the particle turn. When the particle turn or when the particle change a direction, the only way to know when is actually we want to find the time. So you have to differentiate the ds dt. Differentiate 60, you get 6, different t squared, you got 2t, and you must let it 0. Why you must let it 0? Because when the particle change a direction, for sure it will stop for a while before it turn back. So that means we found out that t equal to 3 is whereby the particle turn. Alright, so now we just focus to these 3 timing will do. In between, actually you don't have to waste time to find. So let's substitute when t equal to 0. We want to know where is the particle being displaced to. So we will substitute into 6t, 6 times 0 minus 0 square, so you get 7, right? So the answer is 7. And then when 3, so we will plug into the calculator very fast. 6 times 3, then you minus the 9, 3 square, then plus a 7. That means you take 6 times 3, okay, minus the 3 square, and then you plus with the 7. So the answer is 1, 6, right? Double check. And when it is 9, the particle is where? We want to know the displacement of the particle when it actually at the 9 second. So actually will do. You just find these 3 points will do. In between is not necessary to find unless let's say 2 seconds you have to find. Okay, 2 seconds. Let's find the substitute. 2 is 6 times 2 minus 4 plus 7, right? So we have the answer, which is 15, right? So 15 meter. So if you have time, you can find more points. But at the present, I just use these few points. So I'm going to answer first question in the first 2 seconds. Now let's try to figure out how is the and then when it change the direction, when t equal to 3. Okay, when it change the direction, when t equal to 3, when t equal to 3, the particle is at where? X. And that is very important. The particle is here, 16 meter, right? Okay, then it will change. It will travel to the right, and then it will come back. Okay, when it come back, it will go directly to the left, right? So if you really go and find out the timing, so let's try to find out the timing. You will actually work out more point, and you understand how the particle move. So if I press into the calculator for 1, let's say I want to find out the 1. Okay, let's for 0 is 7, right? Okay, for 1 is actually, let me find out the 1 is if we substitute into is 6 minus 1, 5 is 12, right? 6 minus 1 is 5, 12. Then okay, if I want to find out the 4, will be 6 times 4. Okay, 6 times 4 minus 4 square plus 7. So I got 15, right? It's 5, 6 times 5. for the distance. So total distance, if we count the total distance, we must count the magnitude, right? So it will be 9 plus 9 plus 7 plus 20. So the answer for the total distance is 45 meter, right? Okay, there is an answer for total distance traveled in the first 9 seconds. How about the other question is about the distance traveled by particle at the 7 second. At the 7 second. At the 7 second meaning what? Meaning that, okay, where is t equal to 7? I'm going to explain to you. Okay, t equal to 7 here. Okay, t equal to 7 here, right? T equal to 6, where is the particle? Here. That means particle from 6 to 7, it travel this much. So the answer is just 7 meter, right? So in the at the 7th second, the particle is actually travel with you can write like this, 0 minus 7 or 7 meter, right? So this is the answer for you to find the answer in the 7th second. Alright, so actually maybe some of you would like to sketch a graph which is in terms of a quadratic function, right? If you want to sketch a graph in a quadratic function, it will be something like this. This is a time and this is a displacement. We start with a 7 here, it will go to 16, then it will go, here is 3, here is the highest point is 3 and 16, right? So you have to label in meter. So this is 16 meter, this displacement, this one is 7, you go back to origin. Okay, make sure you understand the graph, and then we have to plot the terminal point. 9 seconds is at the negative 21, the negative 20. So this is a graph that represents displacement as equal to 6t minus t squared plus 7. Alright, so make sure you label the axis in meter, this is in second. Alright, that's all my sharing for today's lesson on total distance. So till then, I shall share with you more video teaching in my coming lesson. Bye bye and have a nice day.